The resistors are said to be connected in parallel if every end of the resistor is connected to the other end of another resistor. To understand this better, let us see the resistors. AB is a resistor, CD is a resistor, EF is a resistor, and GH is a resistor. If I say this R1 and R2 are connected in parallel, that means that one end of the resistor R1 is connected to one end of the resistor R2. The second end is also connected to the second end of the resistor R2. So it is not required that it is connected. A is connected to C and B connected to D as it is. Even if A is connected to D and B is connected to C, still we call it as parallel. That means both the ends of the resistors are to be connected to the end of the other resistor. Now you can see that one end of the resistor R1, R2, R3, R4 are all connected. The other end are also connected. So we call all these resistors as parallel. So in this example also we see that resistors A, B, C, D, E, F are all connected in parallel. When the resistors are connected in parallel, the current through the resistors will be different. That is, a total current is flowing from the voltage source into the circuit, where it is getting split into three parts based on the value of the resistors. If the value of the resistance is high, the current flow into that resistor will be low. Vice versa. If the resistor's value is low, then a higher current would flow through the resistor. And if you see here, throughout the circuit, the same current flows. The current is getting split at this point and it is getting combined at this point and coming like this. One more important fact to be noted is the current is different, but the voltage across the resistors will all be same. Here we see that battery of voltage V is connected, and if we check the voltage across the resistors between A and B or C and D or E and F, voltage will all be the same. The main condition for the parallel connection is that the ends of each resistor is connected. Both the ends are to be connected to the respective ends of the other resistor. And in the parallel connection, there are many paths for the current to flow. But the voltage across the resistor, each resistor will be the same. The current through each resistor depends on the value of the resistance. More current will flow through a low value of resistance and less current will flow through a high value of resistance. When resistors are connected in parallel, say for example R1, R2, R3 and so on up to Rn, if they are connected in parallel, the best way to calculate the equivalent resistance is given by this formula. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by and so on plus 1 by Rn. If two resistors are connected in parallel, then the equivalent will be 1 by R equivalent will be equal to 1 by R1 plus 1 by R2. And when we take the reciprocal of it, we get the equivalent resistance. Equivalent resistance is given by R1 multiplied by R2 divided by R1 plus R2. The voltage drop across each resistor is given by the total current in the circuit into the equivalent value of the resistance. The power consumed by each resistor is given by the formula I square into the resistance in the circuit, or voltage square divided by the resistance in the circuit. Few hints worth noting when two resistors are connected in parallel are: if two resistors of same value are connected in parallel, the equivalent resistance is half the value of the resistance. For example, if two 10 ohms resistors are connected in parallel, then the equivalent resistance is 5 ohms, half of the individual value. If three resistors are connected in parallel of same value, then the equivalent resistance would be 1/3 of each value of resistor. So 10 by 3 will be 3.33 ohms. If four resistors of the same value are connected in parallel, then the equivalent resistance would be 1/4 of the total individual resistance, that is 10 by 4, which is 2.5 ohms. Let us see an example to calculate the equivalent value of the resistance and the current flowing through the individual resistance when they are connected in parallel. Here we see two resistors, 4 ohms and 6 ohms, connected in parallel to a voltage source 24 volts. Let us see how to calculate the equivalent resistance and the current through each resistor. Let us now calculate the equivalent value of the resistors connected in parallel. We see that 4 ohms and 6 ohms are connected in parallel. Now to find out the equivalent value of this resistor, we can calculate like this. 1 by R parallel will be equal to 1 by R1 plus 1 by R2. Here it is 1 by 4 plus 1 by 6. And if it is reduced, it becomes 10 by 24 ohms or 5 by 12 ohms, which when we want to calculate the resistors equivalent circuit, it is 1 by Rp, the reciprocal of it will be 12 by 5, so it is 2.4 ohms. So the equivalent value of the resistance here is 2.4 ohms. The resistors, when they are connected in parallel, the voltage across all the resistors will be same. Now the voltage is 24 volts. Voltage drop across the resistor R1 will be 24 volts and the voltage drop across the resistor R2 will also be 24 volts. If you want to calculate the current through the individual resistors, the current through the individual resistor will be the voltage divided by the resistance as per Ohm's law. Now the voltage is 24 volts. The current through the 4 ohm resistor is calculated as V by R1, that is 24 by 4, which is 6 amperes, and the current through the 6 ohms resistor is 24 by 6, the voltage being the same, the current will be 4 ampere. So the total current in the circuit is a sum of the currents through individual resistors, which is 6 plus 4, 10 ampere. In this particular session, we have seen how resistors are connected in parallel, the conditions for the resistors to be connected in parallel, to calculate the equivalent resistance when they are connected in parallel, and to find the individual value of the current through each resistor. But in practical circuit, we will find a lot of resistors connected in series and parallel. So up next, we'll see about the resistors when they are connected in series and parallel and the ways to calculate the current and the voltage across each resistor. Thank you.